all the way to the Sunshine State. He's here to give us a glimpse into the future of digitalization of buildings, the jet-setting visionary all the way from Germany, Uwe Martin.
Thank you. Good. Hello, good morning from my side. First of all, I would like to say thank you to the whole Q-PAC team. Great event. You did and you do an amazing job. I saw it yesterday, I see it today. The whole factory is blue. I like it very much. So thank you to you guys. Very good. So, why I'm here? I think it was in May. The colleagues from Ziehl-Abegg US informed me, hey, we have the opportunity to participate at the Q-PAC Summit. And I was thinking, Q-PAC? That's the company I know from LinkedIn. They post all the nice stories about, we see it, multiple fan arrangement, retrofitting. Yeah, I fly over from Germany and make a presentation. I think it makes sense. Huh? So, and then my first idea was, I asked my colleague Florian, what's the topic? And if you know Florian Braun, he gave me only one word, digitalization. That's a huge word. What should I do? So I make it a little bit smaller. I will talk today about the future of EC Blue motor technology. And then I was thinking, I'm an engineer, and in Germany we have that huge combined test rig, and we have a lot of fan curves. So I put a lot of fan curves in my presentation. Then I turn around and I recognize, oh, my speech is after the CFO, and he's the decision maker. I quickly removed all fan curves from my presentation. Yeah, so Kevin, sorry, no fan curves in my presentation. Good. Then we start, and I will start with two pictures. What do you see on the left-hand side picture? Yes, right, good. Yeah, businessman, sales guy. Yeah, I see the past. I see a motor without controller. I see a motor without motor protection. I see a motor with any kind of protection, and that's all. It was enough. The fan was running. The question is it enough in 2023? I don't think so. That's the reason why I will talking more about the blue picture here, about the future. On that picture, I see a motor with integrated controller, highly efficient. I see a motor with integrated motor protection, temperature management, and the motor is able to communicate with you. The motor provides a feedback, and that is smart, that is digital, and that is the future of EC Blue motor technology. So, before we start the presentation, give me a few seconds to introduce myself. My name is Uwe. I'm almost 40 years old, from Germany, and I'm working since more than 12 years for the company Ziehl-Abegg in the product management. So, who is Ziehl-Abegg? Good question. We are one of the hidden champions in the ventilation market. We were founded 1910 in Berlin, and after the Second World War, the company was rebuilt in the southern part of Germany, in the village Kündelsau, close to Stuttgart. Nowadays, we have over 5,000 employees worldwide, and last year we are split in two divisions, in the ventilation division and in the drive division. Drive division is more for elevators. For the ventilation division, we have done a sales turnover of more than 716 million euro last year. This year will be a new record for the company, for the group Ziehl-Abegg. It looks good that we reached the first time 1 billion euro. So, we are selling our products to 112 countries in the world with our own sales network. So, we have sales offices everywhere, and we have 16 production facilities in Europe, in Asia, and as well as in the US. Here in the US, we are located in Greensboro, North Carolina, and in the moment, we built a new factory. We expand our production facility to over 500,000 square feet. And my topic today the blue motor behind me, reproduced locally here in the US, in North Carolina. So, cloud connecting. Everybody is talking about digitalization, cloud connecting. In the next, I think 20 minutes, I will explain you how the motor is able to communicate with us, which features are integrated in an EC Blue. And don't worry, if you don't understand my presentation, it's my fault, because yesterday I learned I have the terrible German accent. So it's not your fault. I take it to me, it's my fault if you don't understand what I say. So, cloud connecting, what is the meaning? What is behind the Ziehl-Abegg technology? Cloud connecting is not that simple. So that's the reason why we have looked for some support, and together with Microsoft Germany and the telecommunication company Telecom, we developed our own cloud solution, the ZA Blue Galaxy. Why have we done it? We think in the year 2023, it's important that you have access to the fan every time from everywhere. It's no need anymore to go to the job site to make a cabling and connecting and read out the operating status. You can sit at home in your factory and you can easily support your customers if they need something. I will show you on the next slides. So what have we done together with Microsoft? We developed the cloud system. It's based on the Microsoft Azure platform. The benefit is that platform is according a high security standard. So if we give information from the fan via the internet to the customer, the communication is encryption. So that means we encrypt and decrypt the data, and then it's secured during, let me say, the transport of things. So, and we have worked that our motors, middle-sized motors, large EC motors, as well as our controllers are able to connect to the internet. So we go one step lower from the cloud to the component level. What have we done? First is we have equipped our fans, our EC Blue motors, with intelligent microchips that they are able to communicate with the controller. In that case, the controller is a gateway, and the gateway is the door to the internet, to the IoT. And then it's easily to have access to the components. You can do it also with a smartphone, it's not a problem, but then you have to be close to the fan because the communication is done via Bluetooth connection. The fan and the gateway, they communicate via Modbus. It's more easy, and that's the benefit from our solution. So, have a closer look. Okay, coming to the device management. If you are registered and if you have access to the cloud system, you can easily add the fans to the cloud system. You create maybe a new project, a customer name, a location, and then you add the serial number of the fan to the cloud system. For sure, the fan must be connected via the gateway, and then you have access to the fan, and you can easily add new fans. And if your customer needs some support, hey, it seems to be something wrong with the fan, or can you give me what is the lifetime or the operating status, you just enter to the cloud system, to the ZA Blue Galaxy, you go to the project or to the location online, and then you can check it. It's no need to go to the job site. I give you an example. You have a retrofit project in Greensboro, and you replace, we have seen, that old belt-driven fan by new modern EC Blue motors. You connect them with the gateway, and then you have access to it. And if there's a failure occurs, you get the information, you can easily read out what kind of failure happened, and you can give a better support to your customers. No need to go to Greensboro again, to the job site, and connect something to the fan. You can do it from everywhere, every time. That's the real benefit of the cloud solution. So, additional we have implemented a warning system, alert management. So if you are interested to get not an error message you want to have before something critical happen, maybe a first notification, you can enter a warning value. In my case, I want to have a first warning regarding the fan speed. I enter 400 RPM, and if the fan reach that speed, I get a warning, either via email, via SMS, or via the app directly on my smartphone. And I have a first feeling, okay, something seems to be not running well. Maybe I have to monitor it and to watch that maybe something could be wrong. And then we have a second limit, it's the error message. That's the limit I want to have directly an error message, in my case 600 RPM. If the fan reach now, or increase the speed further to 600 RPM, I get an error message. I know something is totally wrong in the system. Maybe the temperature is too high, or the pressure increased too much, the filter is completely dirty, or something is blocking the airstream. So I get a notification, and I can plan a maintenance, a service case to my customer. And with the alert management, you cannot focus only on speed. Depends on you which information could be interesting for you. Based on the integrated sensors, you can also monitor the motor temperature, the power supply, if the power supply is too low or too high, also the power consumption. Different sensors are integrated, and based on which information you want to get, you can get different kind of warning or error message to the BMS system or directly via email to your computer at home. So, and then we go to the deepest level, the fan telemetry. With the fan telemetry, you are able to detect and to watch over a long time period the fan behavior. That could be interesting to know when the fan reaches some critical limits, or with the zoom function, you can go deeply and make an analysis day by day. So, I give you an example why this could be very interesting. In Europe, we have a customer, he's also doing retrofit projects, and he's very happy with our products. But at one job site, from time to time, he has some issues, the fan is not running fine, the temperature is fluctuating, and it seems something is not really, it doesn't fit together, the complete system. So we helped the customer. We connect our fan to the ZF Galaxy, and over several months, we have collected data, and then we have done some analysis. And we recognized every day at 3 p.m. The vibrations of the fan were very high, that we see and directly influence to the fan lifetime. So together with the customer, we asked them, hey, every day at 3 p.m., what happens close to the job site? And then we found out close to the factory was a train line, and every 3 p.m. a heavy train was crossing close to the factory. The vibrations were transferred from the train to the building, from the building to the unit, from the unit to the fan. The fan is very sensitive. We recognized the high vibration value. The solution is the customer now, okay, at 3 p.m. it's better to switch off. He make a new programming. He switch off the fan every day for 5 minutes at 3 p.m. Normally the train is in time, to avoid critical vibrations to the fan. The result is we have a much, much longer lifetime of the fan. No more issues with not correcting, operating of the fan, no more failure errors, no more error messages. It's running fine. This helps you to improve your system. But before, you have to know and to analyze what is wrong, and then you have to think about how you can solve it. you need to know, you have to register in our program. We have to make some contract with you regarding the data. Can we save it? Have only you access or some guys with you? That's in the moment we have some customers, big and small customers, I think 25 globally for testing. It's brand new, and we try to collect. And then the idea is, if you have a contract with you, you get access, and then you can see the data from your fan you add by the serial number to the system and to your projects.
Are guys bundling this with a preventative maintenance agreement? I guess how is this being sold to the end user? Because I think this is great, and I think it should be a part of a PM, but how are you seeing it being implemented? 'Cause I'm assuming there's a cost associated.
It's difficult to answer because every country has its own data regulations. Who's the owner of the data? The owner, the fan manufacturer, the AHU manufacturer. In Germany, it's different to the US. To be honest, I'm not really deeply involved regarding the US. Maybe later we can have a discussion with our US colleagues. In Germany, I can say we have strict regulations that the owner, the end user is the owner of the data, and you need his confirmation that you can have access to his data. I'm not sure how it's be handled in the US. Similar? In the moment, it's, let me say, on the final stage of the developing. On the next slide, you will see where we stand in the moment, and then we have to think about how we do the business regarding the OEM customers, regarding maybe retrofit customers or something else. The plan is not fixed yet, different solutions in mind, and we have to think about. Good, but thanks for your comment. If you say, hey, that's really helpful to know, it's better to understand. So, at that example with the customer in Europe with the heavy train, we're coming to the smart bearing monitoring. Smart bearing monitoring is really important. Also yesterday from the colleagues we have heard, you have to monitor the fan, and an AC fan is not able to do it. It's not able to communicate with us. An EC motor is able to communicate and can give us a feedback and provide more information. And in the theory, there are 4 cases how you can react in a service case. Case number 1, you're just waiting, you do nothing, and the time has come, the fan breaks down, and then you react. But to be open, this is often the most costly case. Waiting until something breaks down, then makes the service case. The problem is, if the fan stops in an AHU or also in a refrigeration cycle, normally you have to switch off the complete system, and then it's really costly for you. But this was the past. The second case is you make planned maintenance activities. So you plan according an interval. Every 12 months, you go to the job site, you make maintenance, you check everything is fine. And that is how you would like to avoid failures. Yes, better than case 1, doing nothing. But the question is, can you really avoid failures, unplanned downtimes? No. Even with intervals of maintenance, it can occur that the fan, the motor or the system break down suddenly because nobody was monitoring the lifetime of the fan. So, and now from case 2 to 3, we are coming to the digitalization. Proactive. So, you analyze the data, the operating hours, the temperature, and thanks to the communication from the fan, you get a feedback. How many operating hours the fan have already run, how many further hours the fan have, and you can plan proactive, okay, in the next 2 months I have to go to the job site and replace the motor. It's close to the end of the lifetime. And then, case number 4, in our opinion, is the best case, predictive. With predictive maintenance, you can plan the downtime exactly. Not only if a failure occurs, you also have the data and the analysis from the aging of the fan. The calculation of the algorithm consider the aging of the fan and you know what is normal and abnormal activities of the fan, and then the algorithm calculates what is the lifetime and the rest operating hours of the fan. And then you plan the maintenance, the replacement of the fan. This is predictive. So in coming now to the question, where we are at Ziehl-Abegg, this is what we learned also from Microsoft. There are 5 steps. In the moment we are at step 3. And the first step is you make to connect the devices able to connect to the internet, to the IoT. This is we have done with our EC Blue motors, with our controllers, thanks to the microchips inside. And then the last 2-3 years we were collecting data. We know what is our fan doing in the test lab. We have the experience on different applications, but every job site is different. When is the fan operating? How much speed at the day, in the night? So we collect a lot of data, and based on that data, we have created algorithm that we can better plan the lifetime of the fan. And we are in the moment at the stage 3, data analytics. So we have implemented to the fan, to the microchip algorithm that they consider the speed, the temperature, the vibrations, and based on then we calculate what is the rest lifetime of the fan. That you make maintenance when it's really necessary. Not based on a plan every 12 months, not wait until the fan breaks down. Predictive means planning in front, what coming in the next couple of months, and you can look for to order the components. We know sometimes the lead times could be longer when there's a components crisis in the world, so you can plan it directly. And the next part is the Act Smart, that you have in real time the data and you can do the predictive maintenance in the moment. So we are at stage 3 from Ziehl-Abegg, the proactive, and the next step will be predictive maintenance. That's the future, and this is where we are working onwards. So, yesterday we learned what is an EC motor and how it works. And an EC motor with the integrated controller consider around 300 single components. 90% are electronic components. Small resistors, transistors, sensors, a lot of electronic components. But trust me, I have visited 2 big microchip manufacturers. They produce electronic components on that professional level with high security standard, quality standard. Their products, they are really good, and they have to be sure that the small electronic components are really checked, I will say 200% before leaving the factory. So we have to consider the other components. And to be honest, the weakest part of a motor is still the ball bearing. The ball bearing have to cover all the stress, all the loads, all the vibrations from the motor. Especially when we are talking about direct-driven fans with compact external rotor motor designs. The bearings inside the winding, and you cannot replace it. Yesterday I remember the question, why you not make this refilling grease possible? It's difficult to get to the bearings inside the motor. So we from Ziehl-Abegg think you have to monitor the behavior of the fan, especially of the bearings. If you monitor the bearings, if you get more information about the bearing operations, you can make the motor more safe, and you can plan predictive maintenance based mostly on the bearing lifetime. So, and therefore we integrated different sensors. Temperature sensors were already inbuilt in the last couple of years. In the meantime, we also installed vibration sensors for all 3 axes, X, Y, Z. And then you have to know and to understand what is the normal conditions, This was the data collecting we have done the last 3-4 years, that you know what is standard conditions of the bearing during the fan operating, so everything is fine, the fan runs. Then you have to detect what is some unnatural, abnormal vibrations, that you know the normal vibration level and maybe a higher vibration level, because higher vibration level have a directly influence to the fan lifetime, to the bearing lifetime. And then in pink you see it, we have critical bearing conditions. Critical bearing conditions means that the vibrations or the temperature are that high that it's not recommended to operate further the fan, because also we as motor manufacturer, but also we have discussed with other standard motor manufacturers in Germany, it's Siemens and ABB, and all the motor manufacturers say the same. Over 90% of motor damage happens by damaged bearings, and if the bearing really damaged, it normally damaged more than only the bearing. The complete bearing seat is damaged and a replacement is not possible anymore. So the pink critical bearing conditions, you should stop the fan. But you have to know it when it happens. With the cloud connecting, remember the alert management. You can monitor the vibrations, the speed or what else. You directly get a warning when you are maybe in the yellow case, and you get directly an error notification when the fan operates in the pink area. And then we are coming to you guys. What is your job? You have to watch maybe for the fan. Without continuous monitoring, we are in case 1. We are waiting until the fan breaks down. You have to switch off maybe the complete cooling system. The customer is under pressure. The fan stops, it's damaged. I need replacement tomorrow morning. Sorry, Germany already sleeping. So tomorrow morning will be difficult. You understand it better than me. You are sales guys. You know if something happened, the pressure is very high to support the customer. So if a failure occurs, the unplanned downtime can be long, and that's very costly. So better is you continuous monitoring the fan operating. You get a feedback. We learned microchips inbuilt. The motor is able to communicate, to give feedback. If you have continuous monitoring, you get a warning. You see it. Something seems to be wrong. Better to plan maintenance work when it's necessary, that the downtime becomes shorter, that you can better support your customer. So, and then you are at the premium level, you are with continuous monitoring with ZD Blue Galaxy. Predictive maintenance, it's not a future thing in 2-3 years. We are talking about in the next couple of months. We are ready to offer predictive maintenance thanks to integrated communication, thanks to integrated sensors, vibration sensors, and thanks to the algorithm we have created in the last couple of years, that we know, okay, what is critical, when it's critical, including the normal aging of the fan components inside the electronic components as well as the bearing components. And then you can plan early the downtime. You can inform the customer, hey, according my information, I read out from the cloud connected, your fan should be replaced in the next couple of months. He reached the end of the lifetime. The difference between the middle case and the last case is you make maintenance when it's really necessary. In the middle, you react when a failure message occurs. Below, you can react even when there's no failure. You get a feedback about the rest operating hours of the fan. So, you can avoid firefighting operations. You can help the customer to plan it. You can contact Q-PAC, hey, do you have fans on stock for replacement? I need it at that location to that time. You can plan in advance when you make the maintenance job. So, coming slowly to the end of my presentation, I can say digitalization, you cannot stop. If you like it or if you don't like it, it doesn't matter. Digitalization goes on, and we from Ziehl-Abegg think you have to maybe to open your mind and to see new opportunities. If you avoid digitalization, you will lose the race. Think about, hey, how helps me that product, that solution to create new opportunities, to make new business. Amanda is leaving, but you want to double, to triple your business maybe in the next couple of years. You have to think about new opportunities, how you can support your customers. So, Ziehl-Abegg is on track on digitalization, and we think the future is smart, the future is blue, and the future is ZA Blue Galaxy. So, if you have further questions, you can ask me or my colleagues, because now I'm at the end of the presentation. And Kevin, as promised, no fan curves inside. Good, thank you.
Clarify that we're monitoring the bearings, but we're still replacing the entire motor, right? We're not going to be swapping out bearings to, maintain the motor.
In the moment, you have to replace the motor, but we are thinking, because I'm from project management, in the next couple of years to make a next generation where you can replace maybe components from the electronic part as well as from replace the bearings. Especially in Europe, the European Union gives more pressure to the industry to think about replacement, not a complete system, replacement components, and that's the reason why we are thinking of the next generation of the motor, how we can do it. But in the moment, it's really difficult to replace the fan, because also yesterday we learned that if you open the motor, you close it, you have to rebalance, and we know rebalancing is not that easy for everybody. That's the reason why our recommendation is, sorry, yes, you have to replace the motor in the moment.
Is there any is there any special recycling or anything that needs to be done with these motors, or are we just scrapping them once they're done?
Good question. I don't know how it is in the US. In Europe, we try to recycle as much as possible the used composite material from the impeller, also from the encapsulating of the electronics. You can do it, or you can recycle it to the composite recirculation. Copper winding and all the steel, you just scrap it, melt it again maybe, and then you can reuse it.
Got it. I didn't know if there was any benefit to reusing any of the circuitry or anything like that, if anyone is using it for secondary purposes, but it sounds like it's just scrapped for the most part.
Yeah. But consider, in the moment, what you are doing, you are waiting until maybe the fan breaks down. You replace, in that case, you can plan it when it's really necessary. It's not like mentioned to make a maintenance interval every 12, 18 months, and then maybe after 3 months you directly replace the fan, or yesterday we heard you replaced an AC fan, you should also replace the inverter, but you don't know how is the operating status of the inverter. If you have a connecting, you could check the lifetime of the inverter. Is it really necessary today to scrap it and replace it, or maybe in 1 or 2 years? That's the benefit. You use the components over the complete lifetime.
As we talked about yesterday, the methodology the Q-PAC uses is to connect less wires to the fan itself. Is there any movement towards having a handheld device that you can walk up and locally interrogate the motor without having to wire up something additional, without having to connect Ethernet, without having to connect Modbus, but something that we can just touch the fan and get the information off of?
Yeah, we developed a smartphone app, and with the Bluetooth connection, the motor must be able to have Bluetooth stick integrated, and then you can check with the mobile phone directly the fan. But you have to be close to the fan. It's connecting via Bluetooth. Cloud system, You can sit in Germany and then you can check the fans in Greensboro easily every time, everywhere. But yes, possible with the connecting with the mobile phone. So many questions, okay?
Great presentation, Mike Gaza from Schneider Electric. Question on your existing product today. What information is available about motor bearing, motor temperature, et cetera, via Modbus register? Can we just pull that information on a simple Modbus connection today, aggregate it, present it to a BMS?
In the moment, you get informations about the motor temperature. We have twice. We have the winding temperature and the electronic temperature. You have informations about the operating status, the power supply, the power consumption, the speed. Regarding the bearing, that's the reason why the name of the presentation is the future. In the moment, we are not able to provide detailed information about the bearing. We are working on it, and that's the future of the EC Blue motor technology, that we are able to provide more information. For our customers or for you, it will be what is the expected lifetime of the bearing based on the algorithm. In the moment, no, we cannot provide detailed information, but we are working on it, that we are able to do it in the future. Then, thank you for your attention. Enjoy the rest of the weekend.